All right, hi. American Railway Signal Principles and Practices, Chapter 13, Light Signals and Light Signal Lamps, published Signal Section AAR, 30 Vesey Street, New York, 7, New York, revised 1949. American Railway Signal and Principal Practices, Chapter 13, Light Signal and Signal Lamps, revised February 1949. Published by the Association of American Railroad Signal Section 30 Vesey Street, New York, 7, New York. Copyrighted 1949. Association of American Railroad Signal Section. Printed in the United States of America. Chapter 13. Light Signal and Light Signal Lamps. Historically, the sophomore signal was served to the purpose of very well, but it had its limitations due to the height and length of the arms moving parts. The practical was further complicated. Two entirely different aspects were used one by day, the other by night. An effort was made to devise some arrangement where the same aspects could be displayed both day and night. Originally, in the effort of always along the lines of illuminating the sophomore arm to make it visible at night rather than making colored lights visible during the day. Due chiefly to the limitations of the oil lamps, with improved methods of producing electrical lamps, renewed efforts were made to solve the matter. Uniform daily night and signal. Also, the necessity signals, tunnels, and subways began to be present itself. Its light signals was developed in 1904 to take care of the installation of the East Boston Tunnel of the Boston Elevated Railroad. Light signal was arranged to display the indications equivalent to given those in the sophomore signals as night, but as therefore no moving arm to changing the color with the rundell in the front of the light. It was necessary to use the individual lamps behind the proper colored lenses to give various indications. From the fact that light signals were originally developed required no moving parts other than the relay control in the different lamps, it was soon recognized that there was a distinct advantage in their use of sophomore signals, or which can account for the large number of the moving parts. Required considerable labor and materials to be properly maintained, which originally were used in tunnels and subways. It was so soon found that using the lamp sufficient wattage, proper lenses, reflectors, and background light signals could also be used during the daylight to display the same aspects as day and night. The first installation for the daylight was made in 1905 with the New York Central Railroad, in 1906 with the Long Island Railroad, in 1910 with the Pennsylvania Station, New York, New York. There were comparatively short-range signals. The range and spread of light signals vary considerably. The type of the lamp they use, the distributed with the filament to the greater spread. The shorter range, the more concentrated with the filament, the greater the range. The first installation of long-range daylight indicated with the color light signal used in concentrated lamp filaments are currently accurately located and factory adjusted within. Was made in 1949 in New York, in New Haven, Hartford, the railroad. Since 1940, very few sophomore signals have been manufactured. Most of the railroad now installs light signals for both new work and renewals. At present time, 1949, the use of light signals has become so general that there are many types of that they will be grouped into three general classes as follows: color light, position light, and color position light. The aspects indicate for these light signals are fully covered in the Chapter 2 symbols, aspects, and indications. Color light signals, if the name implies the colors are only used to give the direct indications that are similar to the corresponding night indications given by sophomore signals that is red is stop, yellow is approach, green is proceed. Sometimes additional qualifying lights to provide the desired indication. To meet various requirements, there are a number of different types of color light signals manufactured, which may be grouped into two classes: vising long range and short range. Long range signal. Long range signals are generally used to train operate high speeds and desirable observed indication as far as the signal as is possible. The aspect of long range signals can be used from the distance of 2,500 feet to 5,000 feet in daylight. The long range is obtained by the use of the optical effects efficient lenses, reflectors by accurate location of the lamp filament and focal point of the optical system. Maximum efficiency is secured by the use of lamps and having accurately located the concentrated filaments by the use of suitable backgrounds and hoods by careful alignment of the projected beam lenses 8 by 3 and 8 by 8 and 3/8 of an inch in diameter are generally used. Close-up indication of long-range signals are provided through the use of deflecting prisms where signals are located facing the curve of the outer rundell and air added front of the existing outer lens spread with the deflecting beam as desired. Short-range signals. The aspect of short-range signals can be seen in the distance of 1,200 feet to 2,500 feet. They are generally used in tunnel, subways, slow-speed, urban traffic. For dwarf signals, lenses are generally 5 inches to 6 3/8 of an inch in diameter. Signal units consist of iron case as provided in the brackets of the socket for the mounting with the ground and bridge mass, and the individual lenses or units are vertically and horizontally and triangular. Figure 1 shows the style R2 color light signal. Figures 1 and 2 illustrate the signal when using the lens and arranged vertically by space 12 inches from center to center. The use of arrangement is green on top, yellow in the middle, and red on the bottom. This type is illustrated in Figure 2. The lenses are contained in separate cases bolted together one above the other into the form the signal. Figure 2 shows the type D color light signal unit. Each of the lenses unit has known in the double lenses, which is in combination of the two special lenses, by means of which considerable more beam candle power is obtained with a single optical lens. The double-lit in lens unit is illustrated in Figure 3. From this figure, it seems corrugations and step surfaces lenses for each of the other dust-proof of the compartment with a smooth surface exposed. The arrangement makes it very easy to keep the surface clean, efficient with light and transmission. Outer lenses clear glass, while inner ones are colored. Figure 8 shows a double lens unit, one lens, two lens. The double lens units are furnished with a receptacle accurately based on a single line. The receptacle socket supported with a fixed relationship to the lens beginning in the lamp filament to the exact focal point of the lens system, in order that accurately based on the lamps may be interchangeable. The range of the signal are not altered by when the lamp is replaced. The double-lit lens used in long-range signals has outer lens of 8 3/8 of an inch diameter with a 4-inch focal length and inner lens of 5.5 inches in diameter. The focal point of the lens in combination is 1.5 inch back of the inner lenses. Due to the short focus of the combination, the lens collects 155 degrees of effective light from the front of the lamp. The bezel, rings, and frame which hold the two lenses accurately machined so that when the signal unit is assembled, the lens will align and be held there in correct position. Double-lit lens lamp receptacles shown in Figure 3 may be removed from the unit. The lamps may be replaced without changing the focal adjustment, but due to warpage and slight variation in lens, some loss of optical efficiency may occur when the lens is replaced. Or are signals in daylight. Each signal unit is equipped with a background, each lens with a unit with a hood. The purpose of the hood is, as far as practicable, to shield the lens unit from sun rays and protect it from snow and sleet. While with the whole hood, the unit is appearance with being set in the dark. Well, further, the effect flat sheet iron background is used. The signal could also always be located that there could be a natural background to bring out the effect of the light. Artificial background would not be required. Type E color light signal. This goes across. Figure 4 illustrates a horizontal arrangement of lens units that has advantages of close vertical spacing between signal units in the same mass. The construction details practically the same as for vertical type, except for that which may be necessary to arrange lenses in horizontal instead of vertically, as can be readily seen. The vertical type requires greater height of mass, and where the 2 or more 3 indication signal units are used to compare the horizontal type. When indications require the use of 2 or more lights at the same time, the general practice is spaced with single units so that the lights are separated by 4 to 7 feet. To indicate 3 indication units in general use, the illustration of the right side of the Figure 4 shows the back view of the 2 indication horizontals. 1 indication unit sometimes used to qualify this aspects displayed between 2-3 indications. When used, they are sometimes called marker lights. Figure 5 and 6 illustrates the triangular type of the color light signal. The arrangement of a lens used making the comparative signal small size and well suited, but they use the clearance and limited with a closing space between units in the same mass. The desire the construction details in these units are practically the same as for the vertical and horizontal type. The assembly beginning with a triangular arrangement of the unit space about 9 inches at center to center. The circular arrangement of these lenses units may be desired. General red lens is located at the bottom unit. So this is Figure 5, a Type G color light with a triangle, 3 units, 3 lights. Figure 7 illustrates a single design for the subway use. It's equipped with a 5-inch signal colored lens equipped with a 6 3/8 inch double-lit lens. It may be used in short-range signal daylight indication. This signal can be used where clearances are limited in the case of 3 indication units being cast into one piece. Hood and backgrounds are not used in subway signals. Low voltage, low volt wattage screws and signal contact bayonet, candelabra, Base type lamps are usually used. Figure 8 illustrates a single signal similar to Figure 2, except that it's smaller in size. And for use where closed clearances prevail, the type of signal is used in interurban electrical wareways, either 2 or 3 indication dwarf signals. Figure 6 shows a type style TR2 color light. Figure A7 shows an AT color light signal on the side of the subway. On steam rails, while this figure shows the signal as a dwarf, the high signal is similar in all respects except within the case arranged with the application into an iron post instead directly foundation. Signal has 5 inches double lit units, which except for the size are similar to 8 and 3/8 of an inch double lit units previously prescribed. The outer clear lens is 5 inches diameter. The inner core lens is 5 inches in diameter. Lens unit employs the same type of the lamps used in the 8 and 3/8 of an inch double lit lens units. Figure 8 shows the type F color light signals. Figure 9 and 10 illustrate the 2 other types of signals. These signals consist of the cast iron cases with either 2 or 3 openings, which have been applied with the double lens used. The outer lens being 6 and 3/8 of an inch in diameter, and the inner cord lens at 5.5 inches in diameter. The style N type is shorter range lamp, the receptacle for the medium screw base lamp. The lamp's receptacle are mounted in an adjustable bracket so that the man in the field can adjust the lamp filament to ensure the satisfactory indication whenever the lamps are replaced. Commercial medium screw base lamps with semi-concentrated filaments are usually used in the signal. Style N2 signal is similar to style N. The differences being that the type of lamp used, the signal is equipped with a lamp receptacle with accurate located and fixed position at the factory so that the filament of the precision lamp will be located at the focal point of the lens. Combination can be used with lower range than style N. A triangular arrangement of these lenses units sometimes are used to provide a greater vertical clearance for 3 indication lights. Figure 9 shows a style N or N2 color light signal. Figure 10 shows an STN S-style N or N2 color light dwarf signal. And figure 11 shows a style ES25 electrical switch signal. Figure 11 illustrates a special horizontal arrangement, 6 and 3/8 of an inch double unit signal unit with a giving medium range daylight indication of the switch point position. 2 colors are only used and projected in one direction. Lens unit and lamps are used the same as described for the signal illustrated in figure 9 and 10. Other types of electrical switches signals sometimes use the design for the short-range daylight indication. These use is have the horizontal arrangement made with of 2 colors in addition, provided with the indication forward as the rear lens units are made with 3.5-inch diameter lenses from one type of the 5 and 3/8 of an inch diameter less than another type. Searchlight type, figure 12 shows another type of the color light signal unit known as the searchlight signal. It differs from the unit previously described in all of the aspects projected through one optical system. This is accomplished by means of a movable member of the unit placing the small colored disc or the roundel desired color on an optical center line of the signal directly in from the front of the lamp so that all rays from the light sources are projected through it. Figure 12 shows the color light signal searchlight type. The movable member of the unit method of the relay mechanism of the 3 position lights so arranged that when de-energized will assume neutral central position and give the most restrictive indication of the most in the mechanism be either alternating a direct current type. When operated with the alternating current, the polyphase vane mechanism is sometimes used. The direct current mechanism is a combination with a separate rectifier used the operation of alternating current, with the direct current mechanism figure 13 used in motor principles operating as employed. Originally, armature and field windings were used, the armature winding being controlled over the line and the field winding energized locally. For many years, the permanent magnet has been substituted for the field coils, which eliminate the necessity of local energy. The color rondelles are approximately 1 inch in diameter, 1/16 of an inch thick, and made especially developed in the heat-resistant glass, accurately ground and polished. As an additional precaution against breakage, they are spun in a light aluminum frame. Purple and green roundels assembled with a 2-piece designated pre-crack. Signal was originally found within 6/3/8 of an inch, 8/3/8 of an inch, 10.5-inch diameter stepped lenses, having the focal points of 3 3/4, 5 and 6 inches, of respectively different combinations were employed to meet the varying conditions of railroad requirements, such as spread light lines of the curves, and when it necessary to may have a horizontal spread greater than that provided by half the toric optical lenses. Most searchlight signals furnished in the recent years have been grounded or polished in plano, convex, double lit combinations. Outlet lenses being 8 and 3/8 of an inch, with the inner lens approximately 4.5 inches in diameter, having the combined focal length of approximately 2 and 3/8 of an inch. The double-lit lens is much more efficiently optically than any of the signal model molded lenses previously used. The improvement of this efficient due to the element of all molded steps and the use of smooth surface characteristic of the plano convex lenses. Figure 13 shows the direct mechanism for a searchlight type signal. It can be readily seen when the mechanism is de-energized with the red rondelle will be fronted with the lamp to give it the stop indication. When the control circuit energized with one direct, the red rondelle given the stop indication is moved away from another colored rondelle given the different indication moved from the front of the lamp. The control circuit is energized with the opposite direction. The different colored rondelle is moved in the front of the lamp and displays still another indication. Generally, the three color rondelles are used are red, yellow, and green, corresponding with standard aspects displayed on other types of colors light signals. Color rondelles may be used as desired. Reflectors are used to collect the large angle of light of the lamp concentration of the rays so that it will be passed through the colored rondelles. Focus at the focal point of the objective lenses. The type of the signal furnished from the receptacle accurately based on lamp signal precision, signal contact, candela, bayonet pace. Figure 12 illustrates the general arrangement of the signal unit attached with the signal mass and used in high signal. Fundamentally, the signal comprises concentrated filament with the filament located with the focal point of the elliptical reflector, which collects approximately 80% of the light and with its consistent with the focal point of the clear optical lens combination. Light passes through the miniature color rondelle, enters the lens, and emerges a substantial light beam, as is illustrated in Figure 14 and 15. Figure 16 shows the unit and a high signal, while Figure 17 shows the dwarf signal. The high signal supported with the adjustable bracket, which provides the separate horizontal vertical adjustment. The two adjustments with the hairline peep sight at the top of the signal provide an easy means of aligning the light beam. The dwarf signal is mounted with the adjusted base, permitting the horizontal vertical adjustment unit. Figure 14 shows the colored light high signal searchlight type like stepped lens. Figure 15 shows the color light high signal searchlight type plano convex compound lens. Figure 16 shows a color light high signal searchlight type. Figure 17 shows the color light dwarf signal searchlight type. The Type SC mechanism illustrated in Figure 18, two direct current tractive type neutral relays mounted side-to-side mechanism case. A linkage connection between the two relay armatures activates the member of the carrying the colored disc, which arranges the progressive order, usually the red, yellow, or green. With both relays de-energized, the red colored disc is placed before the lamp. With the HG relay picked up the colored disc, it moved to place the yellow in position, and with the DG relay also picked up, moving forward, member is progressed to place in the green in the front of the lamp. Figure 18 shows with the glass removed in the housing of the Type SC color light signal mechanism. The type of mechanism is also furnished to operate a three-position polarized device and necessary permanent magnet rectifier interlocking between armatures, electrical interconnections being self-contained in mechanism case. Both neutral and polar types are arranged with the plug board are automatically connected with the mating of the plug board when the mechanism is installed with a single housing. The plug board in colored lights is displayed with the various signal indications at the same time, provided with a similar aspect of the day and night indication of the position of the light signal was developed. High signal consists of a row of three lamps unit corresponding with the position occupied with the arms of the Cephmore signal. High and dwarf in position, little light signal are available. The high signals are mounted upon the ground mass, single bridge, and cantilever posts. The dwarf signal is usually mounted on the foundation or close to the ground, means with the wall bracket or post. The high signal can be arranged to give indication corresponding with one arm to one arm marker, two arm, and any other combination desired. Each arm and the equivalent can give 1 to 3 or 4 distinct positions. A previously stated high signal is made up of the rows of lamp units, rows consisting of 3 cast iron lamps. Cast cases mounted with 1/4 inch of pipe. The supports exceedingly radially from the iron central hub, equipped with the U-bolts for applying 5-inch in pipe mass. The hub casting serves also as the terminal box of the lamp unit, located on the 18-inch radius about a central lamp. The wires leading on each of the lamp unit passes down through the one through a flexible connection so that the single unit is lined without disturbing the wiring and all parts of the unit being easily accessible. Figure 19 shows the position of the lamp. Figure 20 shows the light unit position light signal. A sheet iron background attached with the pipe at the support means the substantial brackets used for completing the signal. The background of the two shapes, circular and oblong. The circular one is generally used for the top unit, while the oblong one is used where the only necessary to bring out one of the row lights, such as a vertical row of the bottom unit. Figure 19 illustrates the front and the rear view with the typical position light signal. A standard signal platform with extended handrail. Standard ladder provides with a ready access signal unit terminal box when located on the ground mast. The signal unit, the bread signal, is located to make the ladder necessary. The light unit figure 20 consists of the case of the door on each side with the optical assembly. The light source is fitted. The case also fitted with a hood over the cover glass lamps. The receptacle is an accurately based light signal lamp, which is located with the filament of the lamp at the focal point with the reflector, the beam of the alignment with the removal of the sight device. The lamps are single contact bayonet candela type, can be replaced without reflecting alignment and intensity of the beam. The reflector of the optical assembly of the glass of 5.5 inch diameter with the surface toric type. The spread light rondelle mounted between the reflector cover the glass in front of the fan kill screen spreads the main beam 18 degrees horizontally. The top portion of the rondelle deflects a portion of the beam 30 degrees downward for the close eye indication. This glass inclined with the 15 degree of the vertical, so the external light, the reflector from the flat front surface is directed about of the beam in the case or the hood. The cover glass is conical in shape. The amber or slight yellowish tinted glass from the frosted tip. The conical shape of the frosted tip as well as the flannel screen is to prevent reflection of external light. Fan kill screen consists of a series of adjacent equilateral triangular openings with a 1/4 inch long inside, 1 inch deep in the front of the back, located between the light source and covered with glass with reduced reflection external light with the reflector of the lamp. The mounting bracket for the light unit is attached with the case through the ball socket joint with the 4 bolts to permit the adjustment may be necessary for the properly aligned unit. The other end of the bracket is attached with a 1 1/4 inch pipe support. The hood projects over cover the glass sufficient distance to prevent the direct sun rays from striking the covered glass, cutting down the brilliancy of the unit mentioned under the color of the light signal. Figure 20 illustrates one of these lights unit position light signals. Various parts expose one lamp that is used on each unit. Should the one lamp in any of the row burn out and the remaining 2 the other light units light provided with a satisfactory indication. Figure 21 shows the position of a light drawer signal, which is the short range indication consisting of a single case 4 opening for lenses and a door provided with the back to provide the easy wire terminals and lamps. Lenses are located 8 inches from the center lines radial from the pivot units. Figure 21 shows the position of a light drawer signal. On account of the short range only being required with the drawer signal, sandblasted front and frosted glass being used in lenses assembly, not necessary to have the lamp located accurately with respect to the lens as is done by the light unit and for the high signals. Lamp receptacles are mounted on the bracket attached with the case at the back of the lens. The lamps are used in concentrated silicon filament and single contact bayonet candela base type. The lens is clear glass 4 inches in diameter, behind which is a clear sandblasted 30 degree spread light rondelle. The type of the signal, particularly combination of the 2 previous types of the colors, as well as position utilized, except for the 2 lights units are used in a row. The signal shown in Figure 22 consists of the main signal unit when markers line units above below. There are various combinations of marker light units located above and below the main signal unit. The center of the vertical ones being located 7 feet below the center of the main signal unit. Staggered marker light units located with the line horizontal vertical marker light units. The vertical center line 3 feet to 4 inches to the left of the right there. 4th, marker lights using staggered right displayed yellows. All other clear lights. The main signal unit consists of the desired number of the light units mounted on the support radial with the center of the background. The units each of the row being at 2 feet 4 inches center to center. Each light is constructed somewhat along the lines of the doublet unit described under the color of light signal outlet lens being the clear glass 8 3/8 inch in diameter. And the inner lens being the desired color and the marker light unit of the same general construction. Alright, this shows a color position light signal. The light unit in the case of the bolted with the faceplate of the signal such manner to provide individual alignment with each of the unit. The faceplate serves as the background. Focus finders are provided so that when the lamps are replaced, receptacles may be readily readjusted to place the lamp filament focus. Lamps are used to have a single content bandit candelabra base. Each row of the light units sometimes is supplied with a transformer having suitable taps to provide with close adjustment for the lamp voltage. A separate transformer is used for each pair of units, displaying red, yellow, and green or lunar white lights. The color position light dwarf signal shown in figure 23, compact miniature. The high signal contained with the metal case in the units. Each row space 11.5 inches center. Signal center is used in two types of optical systems. The original type of each signal lens with a 3.5 inches of diameter and has flat colored spread light rondelle mounted direct back of it. The newer type of the double lit unit is used and consistent with 4 inches of diameter clear out of the lens and a 2 3/4 inch diameter color inner lens cleaner upward deflection rondelle front of the outer lens. Focus finders are provided with each of the double lit lens using similar to those in high signals. In dwarf signals, it is possible to obtain the signal indication by the high signals marker unit without marker unit, as the cause may be the no top marker unit necessary height of the signal reduced accordingly. Figure 23 shows the color position of the light dwarf signal. Typical local wiring. Figure 24, 25, 26, 27, 28 show the typical local wiring for several types of light signals. Alright. Figure 24, typical local wiring color light. A, B, and C. And then green, yellow, green, A, B. Typical local light for a search light signal. Typical local wiring for the position of the light signal. Figure 27, typical local wiring color position light signal. Typical local wiring for an SC searchlight signal. And then it goes into a test. I believe this is a test. I don't know. Alright. Light signals should be maintained and tested in accordance with the following instructions. Must be vertical mounted with a suitable support signal aligned with the display. Best possible indication approach with the train light. Secure lens fastened. Lens reflector rondelles. Glass lamps must be clean and necessary to ensure good indications. Reflectors must be clean with a dry soft cloth free of lint and abrasive. Actions must be taken when necessary to prevent improper indications due to the reflection of external light. 4. Defective reflectors, lenses, rondelles, glasses must be replaced. 5. Ladders, hand railing platform must be kept in good condition and securely fastened. 6. Doors, cover fasteners must be kept in good condition with suitable gaskets and places so far as to keep out the moisture of the dirt. 7. Housing must be kept clean and must not be used for the storing of material, tools, supplies unless special provisions is made. They should not be opened in severe storm weather except if the conditions require. Electrical lamps must be maintained and tested. Instruction bolt nuts and pins and cotter pins proper size and type that must be kept in place. Button nuts kept tight. Cutters properly spread, and when moved with the parts are warmed to such an extent with creating excessive loss of motion, they must be replaced. Maintenance and repair work which may interfere with the safe movements of the train must not be started until the train movements have been fully protected. The temporary repairs and adjustments when required must be made in such a manner that the safety operation will not be impaired. Tags must be used in insulating material. Wire and tags must be so arranged that they are not interfere with the moving parts of the apparatus. 13 circuits other than track circuits should be kept free of grounds. 14 tests must be made and recorded and instructed. 15. When making the test, if the apparatus proper instrument must be used and must be known that the unsafe conditions are set for the application testing equipment. 16. Manufacturing instructions must be followed unless the conflict with the general detail instruction. With the case, the proper authority must be consulted with the corrective procedure. Color light signal searchlight type. 17. Operating mechanism. When placed in service must meet the shop and the requirements specified on the table. Operating characteristics for the particular type of the signal. 18. Working voltage must be maintained and closely practicable with a rated voltage. Separated armature field windings are used in low current. One element must not be compensated for increasing the boosting and current of the other element above its rated limit. Relay reflector units must be securely fastened in place. 20. Changes in international and internal parts of the signal include the lenses and lamps receptacles must not be made with the original setting. 21. Deflecting prisms are used in care must be exercised to see that they are assembled and maintained and spread the light in the proper direction. Color light, or other than searchlight types, position light or color position light signals. Changes to the internal parts of the signal, including the lens, lamp, receptacles, must be made with their original setting, except for the lamp may be changed, reset when the provisions has been made for the proper focusing. Door cover of the light unit of the color light signal must be kept closed when the train is approaching. And 24. When the deflecting prism are used, the care must be exercised to see that the assembled maintained spread of light in the proper direction. Table of operating characteristics: color light signal searchlights, voltage, contacts, normal resistance, internal charge drop, minimum drop away, maximum pickup in the field energy, maximum field requirements, minimum drop away, maximum pickup working field energy. And it has 3 indications of field coils with contact, 3 indications of field coil without contacts, 3 indications of permanent magnet without contacts, 3 indications of permanent magnets with contacts, 2 indications of field armatures and coils in parallel with contacts. Table of operating characteristics of a color light signal search type continued. Shop requirements: type SC, normal resistance, internal charge, minimum drop away, maximum pickup and working. 3 indication polar neutral, normal resistance, internal charge, minimum drop away, and maximum pickup and working. 3 indication neutral. Neutral, DG relay, HG relay, normal resistance, internal charge, maximum drop away, maximum pickup and working. Precision lighting signal lamps. Precision lamps. The light signal is judged largely by the indicating display of the quality of the indication alignment with the light being virtually affected with the light and locational lamp filament with respect to the focal point of the lens system. Lamps carefully selected with the accuracy filament location to large quantity production. Commercial lamps giving the satisfactory result. Selected lamps, however, they're not available to meet the various style signal requirements of the voltage, wattage, filament shapes. Precision type lamps. Figure 29, accurately based locate the filament within a 1/64 of an inch of the true location of the axle alignment of the light center. The length are necessary to assure satisfactory results. With the use of 1/64 inch precision type lamps enables the replacement being made without need of the readjustment of the lamp receptacles. Figure 29 shows the precision type of the signal lamps marked with the signal precision either base of the bulb type of the using signal contact bayonet candela base and with the filament located with 1/64 of an inch precision for light center length of the axle length. Double filament lamps. Lamps having 2 filaments connected with a multiple having equal rating with the respective voltage wattage. Average life has been generally in use of many years. The theory regarding such lamps have been that normally one filament will outlast the other. The ones that in course of the regular signal inspection, the burnout of the other one filament will not be noted. The lamp is replaced before the one other filament fails, avoiding the occurrence with the dark signal. Practically, it has been found that in most cases both filaments will fail about the same time because they are the same rated life and deteriorate at the same rate. When one filament fails, the other is likely to fail immediately soon after. Due to the increase of the voltage across the filament, usually occurs at the count of the decrease of the voltage drop leads and connections. A later designed double filament lamp combines some of the advantages of both single and older type of double filament lamps, and at the same time eliminate some of their disadvantaged main filament lamps, where a majority of the total wattage of the lamp is concentrated accurately located with the focal area of the lens system. The secondary filament is low wattage, very much larger than the average rated life. Inner light signal maximum efficiency obtained with the light source that is most concentrated, located with the focal area of the optical system. The new type of double filament having the majority of the total wattage concentrated with the focal area of the optical system, produced with the same normal indications due to this corresponding angle of the filament lamps within only slight increase of the wattage. When the main filament fails, the signal indication alterated with the reduction beam intensity of its own main filament failure to reduce the noticeable beam intensity, still sufficient strength to provide a short-range indication of the train operation of reduced speed. It is apparent that the use of the main filament with the secondary filament much longer average rated life greatly increased the probability that the secondary filament would outlast the main filament. Providing the time of the discovery burned out filament replaced the lamp before the failure of the secondary filament, while the occasional failure of the secondary filament before the failure of the main filaments must be expected. Light out protection afforded by the use of lamps makes it their desirable since which will give the better average of performance while the older type of double filament lamps. Or a double filament lamp when the new filament construction available, the A15 bulb rebased and illustrated in Figure 30 for the use of color light signals, S11 bulb single contact bayonet Canderbella base type, illustrated Figure 31 for the use of searchlight, color light, color position light signals. Figure 30 shows the double filament lamp A15 bulb with a secondary filament and main filament. Alright, Figure 31 shows a double filament lamp with a main filament, secondary filament, S11 bulb. Position of filaments. When double filaments are placed with the lamp socket, compliance with the following instructions necessary. The A15 bulb of the Figure 30 rebased lamps to double filament construction should be positioned signal lamp socket so that the secondary filament is back in the main filament. Respective lines as illustrated in Figure 32. The S11 bulb of the Figure 31 lamps double filament construction should be positioned searchlight signal socket so that the secondary filament below is the main filament, as illustrated in Figure 33. Figure 32 shows the diagram showing the position of filament of lensing unit having no reflector, secondary filament, main filament, no reflector, main filament, secondary filament. Diagram showing position of filaments in searchlight signal unit. Best lamp replacement analyzed. Best results can be obtained with each of the types of signal only when the proper type of lamp is used. When such lamps are operated with maintained in conformance with a peculiar characteristic. Modern electrical lamp consists of the helix of the tungsten wire mounted within steel glass envelope. The tungsten wire on the filament as it is called designed so that it is raised the incandescent flow of the electrical current through it with the voltage impressed with the current also the terminals of the envelope is evacuated filled with the atmosphere with the gas in which the combined chemical of the tungsten filament even at the extremely high temperature incandescent. See, depreciation service. Although rapid chemical decomposition of the filament is eliminated, the wire wears gradually at the lamp of the burn process called evaporation. Atoms of incandescent tungsten metal begin throwing off vapor, which condenses, forms a black deposit on the bulb. The life cycle of the lamp is limited, but the time required for this evaporation reduces the wire at the same point. Effective cross section insufficient to carry the current which flows. The wire then fuses at the point, and the lamp burns out. During the life cycle, the aluminum output candle power of the lamp diminishes, partly accounted by the atomification metal conductor, which reduces the wattage consumed, partially as a result of black deposit tungstens which have evaporated. The common type of lamps used in railroad single service aluminum output, which have been reduced approximately 15% just before the lamp fails. The light output of any of the tungsten filament depends entirely upon the temperature in which it operates, which in turn depends on the voltage impressed. The relationship is illustrated in Figure A, curve A of the Figure 34. With the efficiency lamp of the light generated with the device also varies with the filament temperature and voltage. This is shown graphically in curve B of the Figure 34. The curve illustrates the effective voltage in lumens per watt and unit candle power light source emits 12.57 lumens. Figure 34 shows the relationship between light output lamp efficiency and pressed voltage percentage volts by the percentage of luminums or luminums per watt. You have curve A, which is percent of luminums, curve B, percent of luminums per watt. Light output efficiency increased the decreased proportion of the voltage impressed on the light with both the light with the lamp decreasing as the light output efficiency increased. That is, varies inversely with the voltage characteristic of the lamp illustrated by the curve Figure 35. If the results of the fact rate of evaporation determined from the operating temperature of the tungsten wire with a higher operation temperature, this rate is greatly increased. Naturally, very minute variations affected with the cross-section tungsten with large variation of the local temperature or relatively small rise temperature causes the great increase of the evaporation rate. For this reason, the necessary to reduce the variation of the absolute minimum of the tungsten filaments will be made lamps very so light with the practical imposed with the direct detect irregularities measuring devices now available. These variations are small filaments or ordinary commercial lamps are kept within 1 million unit uniformly of the tungsten conductor is no more important than the purity of the atmosphere in which they operate. There are no devices available today which are capable of detecting the minute quantity of impurities present in an ordinary commercial lamp. Of the sealed glass containing the variation which exists in the filaments individual lamps measured, but these two are kept in the minimum. They are being constantly reduced. The introduction of new machinery being developed to replace hand labor, which has also been considered necessary lamp making. 35 shows the variation of the lamp life within rest voltage percent of the life divided the percent of the voltage and the percent of the life line. Once on the account of the three principal factors, other minor ones, the life performance individual lamp cannot be exactly predicted, even though they absolutely control the operation conditions. Only the average life of the group of the lamps within the control of the lamp manufacturer's life is called the design life. Particular light type of lamp is questioned. If all the factors which the bearing on the lamp performance could be absolutely controlled, each lamp in the group would burn exactly the design life. Although perfect control is still not in sight, nevertheless, the deviation of any individual lamp for the average of the relay is relatively small. Your mortality curve. The results of the years of testing have shown that whereas life as any of the one lamp is also known just as within human beings. Nevertheless, life expectancy table may be used in confidence just as it used in life insurance companies in calculating premiums. The lamp mortality curve is shown in Figure 36. The curve represents the test of a large quantity of rail signal lamps. Show the various points throughout the life of the group of the current and define a percentage of the lamps tested will have failed, while the remainder will still have been given service. For instance, if the average life of the group is 1,000 hours, or over 90% of the lamps will stay in function after 500 burning hours. At 750, and over 70% have been survived. At points of the design life and average life made group lamps failures occur more rapidly because of the course. The majority of them will burn out over the near the design life. Few lamps will continue burning considerable beyond the point of the 100% life, compensating for those few that burned out earlier. Figure 36 shows the mortality curve of lamps shown with the life expectancy in any stage of the average life, percentage of the lamps remaining, hours burned per cent of the average. The general shape of the curve is entirely dependent upon the laws of the chemistry of electricity effective with the ability of the lamp manufacturer to make the lamp according to the design laid down by the engineer. It also, of course, influenced by the condition under the lamps operated. The effect of the voltage variation which are meant with the signal surfaces has not accurately determined the data variable to indicate that the signal surface must be in these factors, which will have relatively little effort. Life expectancy of those lamps designated to fail prior to the design life of the group will probably cut off the life lamps with laboratory life tests continuing burn far beyond 100% of the point. But that best time for lamp renewal depends on the operating condition for the railroad. When the traffic is relatively high, heavy natural outrage of the more serious. Also, where cost of lamp renewals required with unexpected burnouts in the high, these outages should be kept at the minimum. Consequently, the renewal should be made earlier in the life of the group of the lamps installed. The design of the signal system also having an important bearing on the ideal time of the lamp renewals. Where the standby lamps are used in signal where the burnout of one or more lamps cannot cause the signal failure, it is less vital for the lamp renewals to be made early. These factors must be carefully analyzed. The peculiar shape of the mortality curve, however, makes it possible to select an approximate renewal point which is applied to the universal in spite of the various methods of signal operation. The different design of the signal now used. This curve is decided in need for the 50% of the life upon the point of only a few lamps which have failed, or after the point failures start to occur rapidly increasing. It can therefore be recommended for the confidence that all incandescent lamps for signal services renewed just before the sharp downward bend in the mortality curve. Faithfully execution of such a lamp renewal schedule will, over a period of years, reduce the signal failure due to lamp burnouts to the 1/10 of the number which would be obtained if the lamps were left in signal until they were burned out. Instructions. Electrical lamps should be maintained and tested in accordance with the following instructions. Lamps must be replaced in kind. Lamps must be inspected and instructed to see that they are burning properly. 3 receptacles base of the lamp must be cleaned to ensure proper connection. Contact care must be exercised with applying Canterbury bayonet base type lamps to see that the pins in the base are turned to the end of the slot and the receptacle forced into the place of the contact spring. 5. Applied voltage must be not exceed the rated voltage. The lamp should not be higher than necessary to ensure the good condition. 6. The lamp should be replaced in accordance with the table of life hours, for the lamp should not be left in service for longer than 5 years. Lamps should be best tested prior to when installed, determining that they are fitness for the use. The use test lamp available apply with the voltage not less than 90% an hour more than rated lamp voltage for a period of 10 minutes. If the filament burns excessively bright after being burned, filament has lost in shining appearance of the bulb bulb is discolored with lamps should not be used. 8. Defective lamps or lamps with a fail short with the time and the table of life hours of the lamp should be sent with the proper authority with the performance recorded. 9. Lamps must be stored with a clean, dry place. 10. When practical, the single lens of roundels reflectors should be cleaned without removing the lamp. 11. Voltage reading of the lamp must be taken each time the lamp is replaced. When the double filament lamps are used, they must be replaced with one filament fails. 13. Double filament lamps must be installed in accordance with the manufacturer instruction. 14. New lamps should be handled as little as possible before placing in service. Jarring should be avoided, but the filaments will not be distorted. Table of lifetime hours shows the 6 volt lamps, amps applied voltage in hours, 8 volt lamps applied voltage in hours, 10 volt applied voltage in hours, 60 volt applied voltage in hours, 115 volt lamps applied voltage in hours. The base upon the average 5% of the less lamps of handling these voltage must be measured from the lamp in a period excessive over the voltage, which greatly reduce the lamp life. And that was American Railway Signals Principles and Practices, Chapter 13, Light Signals and Light Signal Lamps.